Okay, good. We're recording. This is another tricky proof by induction, and I think it actually would be easier to replace this one and one of these ones with Fn plus Fn minus 1 times Fn minus 1 equals Fn minus 1 plus Fn minus 2 times Fn plus minus 1 power n. That's, I think, slightly easier to prove. So we start off with the first one, case 2. So that's F2, which is 1, plus Fn minus 1. So that's F plus 1 times 1. Does that equal oh no, oh I guess the only problem with doing it this way is that the n has to start at 3, does it? Yeah, that's the only issue with starting it that way. So we'll just prove this, which is equivalent to this, but n is greater than or equal to 3. So we might have to prove the first two cases. So I'll prove the very first case in this form just to be safe, and the first case in this form just to be safe. So n is 2, so that's F3 times F1. Does that equal F2? That's a yes. And then this one here, the first case. So F3 plus F1 times F1. Does that equal F1? No, F2 times F1. Okay, hang on, I'll be careful here. F3 times F2, yeah. 2 plus 1 times 2 plus minus 1 cubed. 3. 4 minus 1 is 3. Yep, that's right. Okay. Assume Fk plus Fk minus 1 times Fk minus 1 equals Fk minus 1 plus Fk minus 2 times Fk plus minus 1 power k. And then 3, which is the hard step now, required to prove case k plus 1. Fk plus 1 plus Fk times Fk equals Fk plus Fk minus 1, Fk plus 1 plus minus 1 k plus 1. Now, do I want to start here and try and work backwards? Or start at 2 and try to work frontwards? So I guess I could have cleaned up the original even more. because I could cancel fn minus 1, fn minus 1, fn. So it doesn't matter. Let's multiply this out. So we get fk plus 1 fk plus fk squared equals fk plus 1 plus fk minus 1 fk plus 1 plus minus 1 power k plus 1. They cancel. So now I have fk squared equals fk minus 1 times fk plus 1 plus minus 1 power k plus 1. If I take this over to the left, it changes sign, which would have the effect of just altering the power. This is starting to look promising because I'm getting pretty close to the original. Pretty close to it. So what I can do is I can replace that fk with fk where is it now? Fk minus 1 plus fk minus 2 times fk plus minus 1 power k equals, and I can replace the fk minus 2 with fk plus 1 plus fk, and then that's times fk minus 1. Now let me just compare that. I've got that, and I've got that, and I've got that. So this, so we've proven it. We went from 3 to 2. So we would needed to prove this, and we could assume this is true. So we simplified this until we get back to 2. So that's one way to do the proof by induction. The other way is to start from 2 and arrive at 3. So it works. Okay. So then step 4 then is putting them all together. And then we have it's true for n equal to 3, etc. Yeah, okay. Was it worth doing that replacement of the fn plus 1? Maybe not. I don't know. Not too keen on this one.